Assalamualaikum and salam sejahtera everyone. We continue our chapter summary for the second semester with chapter 8, that is wave properties of particle. We want to investigate the particle either to have the wave properties or not. From the investigation or experiment conducted, it is proven that the particle can behave as a wave. So we come up with an equation. So this is the basic equation for the wave properties of particle. That is lambda is equal to h over p. Lambda is the wavelength. So from the wavelength we can have the wave properties, and p is the momentum. So for the momentum, because it has mv, momentum exhibits the particle properties. So we have lambda is equal to h over p. So lambda here is known as de Broglie wavelength with the constant h, and momentum here is p, and momentum is also can be written as m times the velocity, mass times the velocity. So that is the derived equation of the de Broglie wavelength. If you have the photon as the particle, photon is a light, then you can use this equation. Energy of a photon is equal to hc over lambda, or equal to hf, and frequency is equal to, so the basic equation of frequency is equal to v over lambda, but in this case our velocity is specific for the light, so the speed of the light is symbolized as c is over lambda, so c is 3 times 10 to 8. So that is from 8.1. For 8.2, 8.2 is where we can prove that the particles can behave as a wave because of the characteristic shown by the electron. So electron as a particle, it may diffract, and diffraction is a phenomenon shown by the wave properties. Electron diffraction is actually proven by an experiment conducted by Davison and Germer. So we call this experiment Davison-Germer experiment. For this experiment, we have the electron beam from the heated filament. The electron is emitted from the heated filament, and it will go to this between these two plates. It will move between these two plates, and in between these two plates it has a very high potential. So when the electron has a charge q times the high velocity v, q times v, this q times v, ev is equal to ev, is equal to electric potential energy. So when the potential is high, meaning that it will have the high electric potential energy, and this electric potential energy will convert to kinetic energy. So basically we need the high potential to accelerate the electron so that it will hit the carbon film with a very high velocity. So we have here ku is equal to k kinetic energy, then k is equal to half mv squared. So v here is the potential and v here is the velocity. They are not the same v. So from here we can deduce the equation of velocity. So v is equal to 2ev over m square root. So you will have your velocity as square root 2 ev over m. E is the charge of electron, mass of electron. Then remember we have de Broglie wavelength as h over momentum. When you substitute this equation of velocity to this equation, h is equal to, lambda is equal to h over m square root 2 ev over m. Then using your knowledge of mathematics, you can simplify this equation, and finally the bottom here will be square root 2 mev. That is the equation at the bottom. Then that's how you get this equation. And also, how did you get this equation? Because of ev is equal to k. So you can also express your lambda in terms of k. So in conclusion, lambda can be expressed in the term of h over p, h over mv, h over square root 2 mass ev potential, h over square root 2 mk. So that's all for chapter 8.